Hello, Math 1B. Mr. Owsley's back. This is lesson 4 of remote learning. It's again an extension of what you guys already talked about in chapter 2 of this year. This lesson's all about multiplying polynomials. All right, so it's not just one term times a group, but it's two-term polynomials at least times another two-term polynomial at minimum. So I think you guys will find that the assignment on this is going to be super short. Probably it'll take you about 10-15 minutes to do max. So let's get to it. Now when you take what's called a binomial, I'm going to write this bigger in a red marker. So a two-term polynomial, we called it a binomial, times another two-term polynomial. I'll use a black marker for this one. Now what we did when it was only one term on the outside of the parentheses is we just distributed that one term all the way through. Now what you can do is you can take this binomial times a binomial and split it up into what were to happen if we took the red 2x times the 4x minus 5. Just the red 2x times 4x minus 5. So I'm going to rewrite it as, we know we have to multiply the 2x component by everything in the second set of parentheses. Okay? But we also know that negative 3 is a part of the multiplication as well. So that negative 3 is going to be multiplied by everything in the 4x minus 5 group as well. So I'm going to put minus 3, but representing that needs to be multiplied by 4x minus 5, I'm putting the 4x minus 5 in parentheses there. And that's the trick. Really, all I did was I took a new concept and made it look like a pre-existing concept. The whole idea of, oh yeah, we know how to multiply 2x times 4x minus 5 and then subtract the 3. That's something you guys did on the previous lesson. So let's simplify this. By the way, this is what it means to expand the product. The product meaning two things multiplied together. Expanding it means I want to make a polynomial out of this multiplication. So 2x times 4x, 2 times 4 is 8, x times x is x squared. And then you have 2x times negative 5. The 2 times negative 5 is negative 10. And it's got to have the x at the tail end. Then you have negative 3 times 4x. That gives you negative 3 times 4 is negative 12. Again, an x needs to be at the tail end. And then negative 3 times negative 5. Two negatives multiplied give you a positive, and then 15 would be the product there. Okay, you've expanded it successfully. Now simplify the result. So we've got two like terms here. What's negative 10x minus 12x? Negative 22x. So then the 8x squared gets brought down. So does the positive 15. And this is your final answer. Not much to it. Let's check out the next example. So you got x plus 5 times x plus 5. Really, that's what this x squared means. All right, so don't try to make up rules about how, oh, all I got to do is square the x here and square the 5. Let's just make it appear as if it's an example that we've already done. So we've already done where two are side by side. Let's just turn it into a polynomial multiplication problem where the two are side by side. And in fact, I probably, to keep consistency, should write this in red ink. So now what we do is we split up the first polynomial. We say it's going to be x times x plus 5, the x plus 5 coming from here. And then we're going to add the 5 from here and multiply that times the x plus 5 here. So really, there's no real special case to this, except I wanted to highlight the fact that the answer is not x squared plus 5 squared. It's not x squared. It's not x squared plus 25. It's going to be, excuse me, x squared plus 5x plus 5x plus 5 times 5. So if we were to try to create a fake shortcut of just x squared plus 5 squared, we'd be missing the fact that there's 10x in the middle. And then again, you've successfully expanded that product as well. Let's take a look at the next two examples. All right, so on number 3, it appears that the only difference here is that the first polynomial is a 3-term polynomial instead of a 2-term polynomial. Well, the distributive property is not going to change here. All right, you're still going to take every element of the first times every element of the second. So it's like saying, what's x squared times 2x minus 5? What's 1x times 2x minus 5? And then what's negative 2 times 2x minus 5? And by separating it into by separating it into 3 parts, that's pretty much just visualizing what we're trying to do here. So it's x squared times the second, 2x minus 5. All right, we took care of that one. Then it's plus 1x times 2x minus 5. And then it's minus 2 times 2x minus 5. From there, multiply. So x squared times 2x is 2x to the 3rd power now, minus 5x squared. 5 times x squared is just 5x squared. 1x times 2x is 1 times 2 is 2. X times x is x squared. 1x times negative 5 is negative 5x. And then you've got negative 2 times 2 is negative 4 with an x after that. And then negative 2 times negative 5 is positive 10. At this point, you just have a few extra like terms to combine. So these two go together. Negative 5 plus 2 is negative 3. Remember, when adding and subtracting like terms, you do not change the exponent. A square plus a square gives you another type of square. So it's going to be negative 3, still x squared. Don't try to make it x to the 4th power. The 2x cubed can just be brought down because there's no other x cubed to match it with. These two should go together. Negative 5x minus 4x is negative 9x, and then you bring the 10 down as well. So there's your result on that. All right, the next one is a 3-term polynomial times a 3-term polynomial. Hit pause and try to do that one on your own to see if you've got the right idea with this. All right, if you're back with us, let's see if you've got the right answer. I'll go through it kind of quickly because I really wanted to highlight the 5th example on this. So you should have x squared times x squared minus 4x minus 2 minus x times x squared minus 4x minus 2. And then plus 1 times x squared minus 4x minus 2. Check your work along the way and see if it's matching. Right? Then it should be x to the 4 minus 4x to the third minus 2x squared minus x cubed. And you know what? I'm actually going to stack the like terms as we go along. So this minus x cubed, I'm just going to put it right down there. Actually, you know what? I take it back. I'm not gonna confuse at this point. Well, I won't stack the like terms. We'll just call this negative x cubed positive 4x squared and then a positive 2x. And then everything times 1 is just going to drop down as it is. So no changes inside the parentheses because you're multiplying by 1. Combine the like terms. We've got x to the 4th doesn't have anybody. X cubed, so that'd be negative 5x cubed. Negative 2x squared plus 4x squared is 2x squared plus 1x squared is 3x squared. So these are all taken care of. And then 2x minus 4x is negative 2x. And then minus 2 at the tail end. So check it out and see if you got the right answer. All right, last example. I wanted to show you guys a step-by-step comparison of polynomial multiplication versus polynomial addition and subtraction. The reason why I do this is because this is like the most commonly missed thing that I see people make after doing 2 or 3 weeks of a chapter. They test on it, and this seems to be a bug in their understanding. So, if you notice, this is x plus 2x squared minus 3 in parentheses, side by side with x plus x squared, indicating multiplication all the way. So this one, all we got to do is say we're taking x times everything in x plus x squared. Then we're taking negative 2x squared times everything in the second group, and then negative 3 times everything in the second group. So if you try to map that out, it looks like this. And then you multiply as normal. X times x, x squared. X times x squared, x cubed. And I'm just going to multiply this all out. There is absolutely nothing new with what I'm showing you on this one. Final answer would be 2x to the 4 and plus 3x cubed minus 2x squared minus 3x. And that's it. However, when students see this, they tend to not make a distinction between the two, although there's subtraction happening in between that second group. What happens if there's subtraction in between two polynomials? Well, the last lesson, we certainly didn't multiply them together like we've been doing for the past 14 minutes here. So all you're doing is saying, this example says there's a 1 in front of the first group and a negative 1 in front of the second group if I'm thinking of distributing. So what happens when there's a 1 in front of everybody? Nothing changes. What happens when there's a negative 1 in front of everything? You make everything inside the group negative. Now this is where sometimes people want to still multiply. They want to put grouping symbols around here and do exactly what we did in this example. But that's not what happens when you're subtracting polynomials. At this point, all you do is combine like terms. 2x squared minus 1x squared is a positive 1x squared. X minus 1x, well, that's a 1x minus 1x. They cancel each other out. 0x, no x's, and then a minus 3 remains. So there's a big, what I wanted to do was highlight the huge difference between, this is subtraction, this is multiplication. Completely different. All right, there's 5 problems on the assignment. You guys should really rock it. See ya.